All right. So good morning, good afternoon, everyone. Welcome for our new webinar. This is Damien. We are going today run the webinar about the following topic: the protect and access removable pacifier protection for a vessel by a Benarx, safe, strong, and smart protection up against the hydrocarbon fires. Yes, so short introduction about the presenter. I will start first. So my name is Damian Kumorkiewicz. I'm Global Technical Sales Manager for Benarx Epoxy Products. I've studied oil and gas engineering. I'm working for over 8 years in Berenberg, which is now part of the Altad Group. And in total, I'm working in the oil and gas industry for the last 12 years. Nice to meet you all. And together with me, we have a second extinguished guest, Adrian Christian Holland. Adrian, your turn.
Hello, my name is Adrian Holland. I'm engineering and R&D manager for the Benarx Epoxy series here in Berenberg Altrad. And I've been with the company for over 11 years now.
Yeah, all right. So so let's start with a quick reminder. What's the pressure vessel actually is? So the process vessel, it's a sealed container used in oil and gas facilities widely to hold, separate, and treat fluids and gases under control, pressure, and the temperature. Common devices are following, like separators, dehydratators, treaters, and reactors. Because those process vessels, operate under the certain conditions, they require the safety and fire protection measures, very often also with a thermal insulation performance. So how the vessel is made up? So in general, either process vessel or sphere, they containing number of the items. The main component, of course, is the shell. Shell in general holds the primer pressure boundary and is the largest area of the vessel. From two ends, you have a hatch or enclosure, and those components are normally much more complicated because of the curvature, so it's more complex geometry. The vessels also containing a number of nozzle and the flanges, which are connecting points for upcoming piping and flanges and other interfaces. And for manway entries, the vessel contains manways or manholes. So of course, in these particular items, removability is very important, since from time to time vessel needs to be cleaned. Another components to structurally support the vessel itself, if it's vertical or horizontal, or if it's sphere, then we need to use either the saddles, skirts, or supporting legs. Saddles are normally used for the vertical vessel, while skirts and support legs are used for vertical vessel or spheres, respectively. There are also a number of other internal components, like lifting lugs, like ladders and others. Where are these vessels placed in oil and gas facilities? So in general, as you know, oil and gas facility is really broad. We have an upstream, we have a midstream, we have a downstream. So there's a number of different applications for the vessel depending on the process the facility operates. But in general, for refineries and petrochemical facilities, normally these facilities are cracking units, polymerization vessel, aromatics, and others for going through the gas treatment, gas processing, and gas treatment facilities. There's amine vessels, it's mercury removal units, and LPG, LNG bullet tanks and spheres. Then offshore, this is floaters and offshore platforms. The most common vessels are low pressure and high pressure production separators, test separators, scrubbers. And the last thing, which is LNG facilities. The vessels are normally liquefaction vessels, boil of gas treatment vessels, and others. All right, but why we use the passive fire protection on the critical vessels first? So of course, as a starting point, the vessel needs to be in the fire zone, which are nominated by performing risk assessment studies by safety engineers, or if the project follows the API 2218 standards. But in general, the vessel and the spheres needs in overall passive fire protection, because due to the gas containment, these vessels are especially at the risk from a hydrocarbon fire exposure. And if active fire protection fails, which is another type of the passive fire protection solution, the heat can cause the vessel source to boil and expand in a boiling liquid expanding vapor explosion. This we will touch in the next slide. A little bit more details, and damage caused by resulting the fireball and flying debris can be devastating for the project. So this is really serious threat for the project. So yeah, in general, as a summary, contain the high pressure and flammable materials. Those vessels are often in a congested area, especially in the offshore environment. Very often, the passive fire protection material supposed to be in the same time both PFP material and insulation material, and must be made accessible for a maintenance, inspection, and repair. Yeah, so that's the example of boiling liquid expanding vapor explosion. So yeah, as a couple of basic phenomena, it's worth to start why what's the boiling point actually. So boiling point is the temperature at which liquid becomes gases throughout. So that's number one. Number two, the boiling liquid expanding vapor explosion, it's caused by a rupture of the vessel and containing pressurized liquids above its boiling point. So when the vessel fails, the pressure drops immediately, and the hot liquid boils, generating the large formation of the vapor. And due to this, yeah, that's if the material is flammable, then it can create the large fireball and cause very big damages for the surrounding area. So this is really serious threat. We would like to show you one of the many fire incidents it was in our industry. This is one of the most dramatic. It comes from 1984, from November. It happened in one of the LPG storage terminal in Mexico City, in Mexico. As a result, 600 people killed, 7,000 people injured, 200,000 people being evacuated, and the terminal was completely destroyed. The end user lost a lot of reputation. Yeah, governmental agency being, of course, involved. It brought a lot of attention from the media. So it was really, yeah, very, very, very bad event for our industry, and of course for those people, either neighbors or people who has been harmly affected. So yeah, this is not a coincidence. This is one of the example which happened in our industry. Okay, so going forward, what's our typical traditional methods for a PFP on the pressure vessel? I think this is the good starting point before we move into the Benarx system. So you can divide those solutions for two categories. One category is dynamic, and second one it's a static. So static passive fire protection materials are like sterile glass shells, which is rigid product, closed cell insulation material, together with a metallic jacketing, for example, 316 or 304 stainless steel. The another solution is a PFP jackets. also used many times in the industry for a PFP of the vessel. It's made from a technical fabrics, and it's filled with a thermal insulation material as a fire insulation material, which is mineral wool, fiberglass, AUS wool blanket, and similar. The last one is a ceramic wool fire insulation. It's quite flexible as well, and it has to be applied on the vessel together with a metallic jacketing. Another type is, of course, the dynamic PFP materials like intumescent coating, the epoxy intumescent coating. It's applied on site by the applicator. It's swelling when it contacts with a fire, creating black insulation char, and it's very often used by offshore industry, while historically first of all, lightweight PFP being utilized as active dynamic pacifier protection solution. All right, what are the drawbacks of traditional PFP solutions? So yeah, you have many different systems now on the market. Each solutions they have a pros and cons. But what we see based on our experience, it's first of all corrosion under insulation, big topic in our industry, in our discipline. There are a number of locations in the vessel which are suspicious for the corrosion, and it could be, for example, the saddles as one of the example. Then a congested area, especially in the offshore environment, there's very little space in the production area. So yeah, there is very little space. There's a lot of surrounding equipment like ladders, decks, etc. We see also the pressure vessel lifetime is expected they are designed for a 15, 20 years. And we see by the project, they utilize the solution which can withstand only 5 years. So of course, in that logic, the PFP system will be one of the first component to be repaired and be undergo of the maintenance and the first turnaround or shutdown. Impact resistance, of course, during the shutdown, there is a lot of hassles, scaffolding, people step in, step out, laying the heavy equipment, everything is in a hurry. So of course, the PFP might be damaged. So worth to take into account these conditions too. And inspection, of course, these critical vessels needs to be inspected according to the inspection program. So yeah, it must be inspectable. So this is our solutions. It's called Benarx Epoxy Panel. So how it's made? So it's made from a perforated plate, stainless steel 316. And then it's covered with a epoxy intumescent coating, which is calculated based on your fire demand criteria. And then it's applied with epoxy primer and polyurethane top coat on top of that. And then from an inner side, we attached aerogel blanket called Oriza aerogel blanket. It's pre-cut, laminated with aluminum foil and glue inside inner side of the panel. So the thickness range is depending on the PFP specification and the rating, but it varies from 8 up to 40 millimeters. The weight is starting from 11.7 kilograms per square meter, but it's connected to the thickness directly. Of course, the higher thickness, the lower weight is expected. Surface temperature, in theory, we don't have any limit. We can even go up to 650 Celsius degree, but it's very, very rare. With a one layer of aerogel blanket inside of our panel, the surface temperature is up to 250 Celsius degree. So it covers most of the cases in the industry. We see that the vessels are rated normally up to 200, 220 Celsius degree. Fixing methods, yes, that's depends on the accessibility, about if the client wants to have a frequent access, etc. What's the most practical for the installation, but it's locks or bending or pop rivets or combination of them. Just since aerogel blanket is internal component of our system, I think it's worth to mention a few words about that. So we use this aerogel blanket. insulation material, which is hydrophobic, water repellent insulation blanket. So it's very, very good. It can be used as a standalone product for a hot conservation and acoustic insulation or cold conservation for the vessel. So if you have any of this demand, feel free to contact us, and I'm sure we will be able to help you. It's widely tested and certified. So here you have a list of the certification here as well. It's manufactured in a very many different thickness variation, 3, 5, 10, and 20 millimeters. So yeah, this is not a major topic for the webinar, but we think it's worth to mention. So what's the details of the fabrication process? So it's not rocket science fabrication. In general, when we start the fabrication, we start with a skeleton. So skeleton, we start making the skeleton according to the object shape. Then we apply the epoxy intumescent coating according to relevant thickness. We apply the epoxy primer and polyurethane top coat and a roller inside. And then it needs to be dried, packed, and shipped to the client. That's the whole process. How our panel works. In overall, if you are familiar how the epoxy intumescent coating works, then you know how our panels works, basically. We use Chartec as an epoxy intumescent coating, so our panel works exactly the same manner. In contact with a fire, it starts reacting, expanding, creating the black insulation char. We protect the equipment up against the fire. Then product configuration. So we have a number of components which can be attached to the product, but not all of them that are mandatory. We use them when it's necessary. So first, air gap. That's a small distance between the metallic substrate in our panels. For example, 20 millimeters air gap. So it's a great solution up against the fire because water will not be trapped between the panel and the metallic substrate. It always go to the bottom of the vessel and will be drained. The water will be drained out from the system by a fire-rated drapers. Then Teflon spacer, together with supporting rings. Sometimes we need to attach the supporting rings, which are mechanically fixed around the vessel, so no welding. We do this especially for vertical vessel, so we need to attach the panel somehow to the vessel. So we use these supporting rings with a Teflon spacers. Watershed, yes, it will allow water to run off. Each panel section is equipped with a tack plate. We can incorporate the inspection hatch in any panel location. Its bottom section of the panels are always equipped with a fire-rated drape plugs, which drain water out from the system. And between the panel sections, it will be sealed. The joints will be sealed with a recommended sealant, and any minor gaps between the panels, like up to 5 millimeters, it will be fulfilled with expandable tape. Here you have since we already explained a little bit how the vessels are made up, we would like to just show you how our product fits into those vessel components. Here you have an example of panels on the tank shell. Then you have the epoxy box, which is exactly the same product like a panel, just different geometry on the saddles, on the sliding saddles. Then you have the nozzles and the manholes. That's one of the typical drawings we make of our panels for the client, for the project. So, but what might be your additional questions? Why we have several parts? So in general, we have a certain factor we need to follow when we design those panels. So the number of sections or panels depends on the fireproofing thickness, based on the application, based on the weight restriction, based on the surface area to be insulated, based on the accessibility. So there are a number of factors we need to follow, and our standard weight restriction is 25 kilograms per segment or per section. If you have a lower demand, for example, 20 kg per part, then of course we can follow that, but we need to increase a little bit number of the sections in total. The part will be smaller, but will be more quantity of those panels. Here we have an example of the panels on the vertical vessel. Later in this presentation, we will show you one case study from such application. But again, sometimes we saw demand for a PAP on the vertical vessels, and they are a little bit more complicated because it's vertical. So you, especially for large vessels, you need to take into account the wind speed and additional conditions. So we use normally supporting rings around them, which are mechanically fixed to the vessel, and then and between the rings and the vessel, it's a Teflon spacer, and then we attach the panel. So it's very similar fixing methods like you use, for example, to insulate the vertical vessel with mineral wool. You need to use the supporting ring as well. So yeah. All right, Adrian.
Yes. So I will talk a little bit about the testing and certification that we do for our products. Why do we do it? Well, first of all, it's our license to operate. We are not permitted to deliver our products in most projects without appropriate fire testing and certification. Number two, we always invest to improve our products, reduce thickness, reduce weight, reduced cost, reduced installation time and POB for the clients. Here's a short list of some of the testing that we do for our Benarx series products. For hydrocarbon fire, we typically test according to BS 476 and IMO 754. We've also done some GOST and TR testing historically. Of course, one of the more recognized standards, UL 1709, we have testing and certifications up to above 3 hours. We've also done Firestream host tests, which we will come a little bit back to later. And then we have our jet fire testing, both regular according to ISO 22899 and high heat flux, so-called 350 kilowatt tests. We've also done some sporadic testing within cellulosic fire for building fires. We've done explosion testing. The presentation says 1.2 bar, but we recently did testing up to 8 bar there. So we are quite advanced on that front. And then we do mandatory weatherproofing testing, like cycling testing according to ISO 20340 or the recent updated standard according to NORSOK M0501. Acoustic testing for acoustic insulation, and then for our fire protection series, we also do cryogenic testing, which is relevant for LNG facilities. We also have some other testing, like non-electrical discharge test, to verify that our products does not generate static electricity in operation. Here's an example, a short video taken from outside the test facility of during one of our previous cryogenic tests. For one such test, we are utilizing almost a full tanker of liquid nitrogen. So and this can also be done with hydrogen if needed. The specimen is subjected to a jet of liquid nitrogen, typically for 1 hour. Exposed to temperatures down to -200, and after 10 to 15 minutes of completing this cryogenic test is subjected directly into jet fire, going straight up to 1100 degrees and completely engulfed in flames. Why do we do these tests? This test is meant to address the concern that a spill of liquid natural gas will cool the steel temperature below its brittle transition point, to the point where the metal can actually be subjected to brittle cracking or failure due to the cold temperature when opposed to shocks and other loads. Yeah, next slide. Then we also do explosion testing. This is from an older test where the test specimens are located in the front of an explosion container. The container vessel is filled with an explosive mixture of air and propane in this case, and when it's detonated in the back end, the pressure wave builds up, and typically the more congested you have these process areas, the higher the pressure will build up. So the more complexities, the more piping, the more flanges and valves and structures and obstructions you have in the process facility, the more the turbulent flow of gases will mix and the higher the explosion pressure will build up. The test specimens are located in the end, and they have to withstand this explosion load, both the impact and the subsequent drag load. This is an example of a jet fire test, in this case for a panel arrangement. We test different configurations, sometimes piping, sometimes structure, sometimes beams, in order to address the different geometries and the strengths and weaknesses of the system in different sizes and shapes. In this case, we've encompassed I-beam section on the face of the panel in the back of the jet fire box here to test whether the corners of this I-beam section would represent weak spots in the jet fire scenario. I'm happy to say the fire tests withstood the 2 hours envisioned, and yeah. And this is how it looks. This is for a piping test, and you can see the sheer velocity and turbulence and erosion going on. The thing about jet fire is that it's not only the temperature, like the heat radiation, it's also the turbulent stream of gases continually eroding and sanding away at the PFP. When we do testing, we also encompass different complexities, like in this case, an inspection hatch. And these pictures shows you a little bit how a Benarx epoxy box will look and react during a jet fire test. This is a fairly thin box, so you will see that the PFP is actually eroded away. You can see the steel coming out on the middle top picture here. And then, of course, we have the Charcotec on the inside, which helps to protect the object during the later stage of the fire. We included an inspection hatch to test that this does not represent a weakness in the system. And on the bottom here, you can see an example of a cable tray configuration test where we actually run electrically charged wires inside the cable tray to see that they could actually withstand the rated current during the fire scenario. These are some pictures for an example for a cryogenic and jet fire test. So as I mentioned earlier, first you subject the test specimen for an hour of liquid nitrogen jet. So you basically high pressure wash the specimen with a massive stream of liquid nitrogen. For this test, we used 7 tons of liquid nitrogen. So that's, yes, that's 2/3 of a full tanker truck. And after 1 hour of this frost inferno, it's going straight into the jet fire. And it has to withstand. It cannot fall apart or crack or delaminate. It has to prove integrity for the full fire duration. In this case, the jet fire test was run for 1 hour, but we've run for up to 3 hours of jet fire testing subsequent for 60 minutes of cryogenic. Yeah, yet another test, CSP and jet fire test. This was for the thick pipe specimen, so up to 40 millimeter. And we also do thin specimens. This was part of a test program for Chartec 2218. The goal of the test program was several factors, but one, to transition into a boron acid-free system, which is HSE concern for some operators. Also to reduce costs by going into more efficient technologies, reducing thickness and complexity and cost of the system. And due to the thickness reduction and the higher distance between locks and bands tested there, we actually achieved a almost 20% reduction in cost for the product just by transitioning Chartec technology. This is for the same program, just for the structural specimens. Here as well, 60 minutes in the subjected to the liquid nitrogen, and then for 120 minutes of jet fire in this case. New member of our test reports, the stream host tests. This is quite a new standard for us, I would say, even though it's been a couple of years ago now. It's an American type, I would say, test designed to simulate the effect of an impinging fireman hose on the specimen. So in the case of fire, there might be cases where water cannons or active fire measures may be taken. And the purpose of the test is actually to see that the impingement of the fire hose water jet does not compromise the system mid-fire scenario. So in the test, we're doing 20 minutes of jet fire, 10 minutes of water hose spray, and then another 20 minutes of jet fire. And the system has to withstand the water spray without cracking due to the thermal shock or that type of thing. Here's a screenshot from a high heat flux test. This is the beefed up version, the jet fire on steroids, the 350 kilowatt jet fire. And basically it's a bigger furnace, it's a bigger fireball, and it's a much higher temperature as a result of the increased opacity of the fireball. The thing to note here is that even though you have a product that can withstand a regular jet fire, the 100 to 200 hotter temperature normally encountered in a 350 kilowatt jet fire test actually represent something like a 50% increase in heat flow. So we've seen fixing materials that stood 2-3 hours in a regular jet fire be burned away in the course of 15 or 30 minutes. In some cases, these tests reach temperatures above the melting point of certain stainless steels. So it's on the edge of what a system can do, and you cannot extrapolate from regular jet fire testing to this type of test. They have to be performed on their own merit. Yeah, some examples of cyclic testing, weather exposure test to explore different type of coating systems and sealants and see how they perform when subjected to UV light and rain and salt and cycling temperature. And also we've done some testing on repair systems. So the concept here is that we've tested damaged PFP encapsulated by our system, so that in the case that you have damage, cracking or delaminating PFP, from a fire protection standpoint, you don't actually need to remove them before installing the Benarx epoxy system. You only need to remove them if you have concern about corrosion. If the corrosion protection primer and integrity of the system is good, you can actually just clamp on panels and boxes and avoid the chiseling and removal of the wet applied system. Yeah, there's a lot of documentation that goes into deliveries like this, a lot of design, a lot of engineering. We supply our standard documentation package if as a default. It includes data sheets, installation manual, drawings, PFP thickness reports and certificates for the projects, weight reports, certificate of conformance, and packing list. Of course, many new build yards have much more extensive requirements for documentation, which is required from the project, and we follow those if they are required. But of course, they have an additional engineering cost in terms of hours. So we would like to recommend to keep it simple if possible. Yeah, in the design, we also do some explosion testing for those cases where explosion loads are concerned. Different boxes and panels have different sizes, supporting mechanisms, shapes and geometries. So we run final element analysis to address that. The explosion load that we run in our tests is adequately captured in the strength of the geometry that we deliver in the project. Here you have some example of a vessel skirt and a pressure vessel. So yeah.
All right. Thank you very much, Adrian, for your engineering and technical workflow. So now we can briefly explain you how we deliver our products. So basically, it starts with a design methods, and design methods we'll touch in details in the next slide. But when it's defined and we measure or design based on the 3D model, then we start doing the PFP thickness calculation. We start preparing the agreed project documentation. Once everything is in line, production, inspection, then we shipped. The installation also needs to be agreed. Normally, we see the clients prefers to use local workers, so they can easily install our product. And sometimes we are requested to supply the field supervisor. If everything installed correctly according to the deadline, then we sign just the papers. And on the bottom side of this slide, you can see the photo of our factories. One is in Poland, and the second is in Thailand. So we can really, we are prepared to supply demanding volume and with a quite tight pressure delivery dates. This is for us bread and butter. Well, when it comes to the design methods, as partially mentioned in the previous slide, we have a number of solutions, so we will not leave you alone. In general, we can utilize certain models. So first of all, we can design those panels based on the 3D models, like from your Navy's work. We see the correctness, quality of the 3D models improves every year. So this is not like 10, 15 years ago when valve was represented by the rectangular, for example. Now becomes really, really good and accurate 3D models. It could be also 3D scans, either from the client or from our side. It could be also point of the clouds. It could be field measurements or just vessel drawings with the side pictures. We can also do the collision test in your 3D model, or we can send you the 3D model of our panels, and you can incorporate into your 3D model. We are flexible, but the goal is to detect any clashes, especially offshore projects that are concerned about that, because they're concerned about the PAP thickness, the weight, if it's fit into the very congested area, very little space. So sometimes we are requested to do so. Well, except the material delivery, of course, we are able and prepared to provide you the service capability. We have a number of the models. We can send you the field surveyor still, despite its traditional method. It works pretty well for complex scopes, for large vessels, for example. It's just easier sometimes to send the guy and measure it on site and discuss all nearly impossible scope of the works. For some of the project, we can also supply our labor, our installers. However, we see the bigger and bigger trends that projects prefers to use the local manpower component, not just because of also the price, but also because of the local requirement, local content usage requirements by a government. So we are definitely able to help you with this as well. And we are quite often requested to supply the field supervisor. So field supervisor will train the local workers, will also the end user workers. It will the supervisor will supervise the ongoing works, and in case of any modification to be done on site, that person will be in charge of this activity. Yeah, Adrian.
Of course, to install the products, some tools and fixing materials are required. And of course, this is not the list of what you need every time, but it's an extensive list. So for some of the things that might be required. Typically, very few tools are actually required. Standard insulator tools like a hammer, jigsaw, drill. We'll use rocker strip gasket as a fire intumescent tape to seal minor glitches and openings due to inaccuracy in cutouts, etc. some measurements. Yeah, it's quite rudimentary and simple tools to acquire. We have different models. As Damien said, we are flexible, so we can either supply the full insulator toolbox for the project, so you will get all the tools pre-packed and ready, or we have cases where the client want to procure the tools locally, maybe due to import restrictions or local content or whatever, and we can provide a list of and supplier names of tools advised. So yeah, if the client want to do it themselves or if we should send the tools, we can do both. One concept that I would like to elaborate a little bit on the installation part is the flat pack panel. We have had some projects where instead of custom designing and fabricating everything, we're actually sending standard building materials. So we're fabricating standard panels, standard angles, standard latches, etc. for the clients, and they will cut on site and adapt to the field conditions. This might be good if you have a low quality model, so there's a high risk of the clash, or in the cases where you have large surfaces, you can use the flat panels efficiently. Or on some like structural nodes, manholes, nozzles, etc. You can actually fabricate boxes on site without the need for surveying. This, of course, adds on to the work on site compared to the everything is pre-designed case. But it is a concept that you can use if labor is cheap and you don't have a POB concern. It's possible to be quite flexible on the design and get a cheaper material price.
All right, thank you, Adrian. And then, yeah, if I would be end user or EPC or insulation contractor, this is, yeah, the most interesting part would be for me the case study, and the reason why, because hopefully we will be able to give you the case study that possibly it might solve your potential problems or issue on site. So one of the first case study, this is from gas processing plant in Norway. We supply the panels of the sliding saddles, and as you most probably know, sliding saddles, they have this movement up and down from a 5 up to 10 millimeters due to the thermal expansion of the vessel. So of course we need to accommodate this movement, and we need to make sure that the panel will be big enough to accommodate that movement. So here you have this example where we supply those panels of the sliding saddles and also associated piping with the flanges. The shell, the tank shell was fireproofed with a fire insulation material with a metallic jacketing. So this is a great example of the hybrid PFP system. Then the case study number 2, it's for this time vertical vessel. So the top of the vessel contain the bolted connections. So they need to have access from time to time to this bolt area. So that's why they use our box assembly solution on top of that. So it's quite large. It was quite large box, and other remaining area down to the bottom was fireproof with a wet applied PFP. Yeah, this one of the most favorite case study, a little bit unusual. This is for offshore platform in Norway. We fireproof around about 70%, 75% of the vessel. So only bottom section of the vessel being uninsulated. And the reason why that was related to the boil of gas behavior. So when you insulate the entire vessel, the tank becomes too cold. So it can produce the excessive amount of the boil of gas. So to balance this, the project want to keep the bottom section of the vessel uninsulated. So that's why. So we supply these panels on this markup area of the vessel, and apart that the client here on the side, as you can see here, There's very little space, very complex area, tight spaces. Yeah, it was pretty tight deadline as well to supply our solutions. This is how the outcome looks like. We have to utilize the supporting rings with the Teflon spacers due to the large vessel. If I could remember, the length of the vessel was nearly 50 meters with a diameter over 3 meters. So quite a lot, and the temperature here, the operating service temperature was around about 120 Celsius degree. So yeah, we have to do some on-site cuts out and openings and the partners to accommodate all these details and remaining photos from that project. So yeah, client was happy in overall. Another case study, this time we repair damaged PEP on the vessel. So what client used in the past was ceramic wool insulation with a metallic cladding on top of that, but it was fully corroded, it was fully soaked with the water, it was very, very heavy. So once the client removed that, we came to the game. But the small starting issue for us was the client didn't have drawings. The drawings just evaporated. And we have to do the 3D scanning, and based on this 3D scan, we got the 3D model. Due to the urgency of the scope and potential grid danger for the people machinery, surface treatment with a wet applied PFP was an option. The client wanted to avoid this, and it was really complex area. So yeah, this is our panels on those tank after the design. And here you have a picture after the installation. So yeah, we managed to fulfill all the expectation. Client was pleased with the overall performance. Worth to mention that some of the section we didn't have to fireproof like saddles because they've been already fireproofed with epoxy intumescent coating a long time ago. So here you can see interfaces too. Another project, now we are moving to Netherlands, to the Benelux. We are in the refinery for our good customer. We supply those panels on the components called pre-filter and coalescer. Those vessels being already insulated with mineral wool. I think it was 100 millimeter, if I could remember the thickness. And these vessels also contain the heat trace, and heat tracing is vital for a process stability, to maintain the temperature, to avoid fluctuation, and to maintain the viscosity of the fuel they process inside. So yeah, we make the measurements on site, and external insulation subcontractor installed those panels under our supervision. Everything went well. As you can see here, the supporting glass was fireproofed with an intumescent coating, and this is an example how our panels looks like on the vertical vessel, including some small associated components like nozzles. Yeah, now we are changing continent once again, so we are flying very quickly today. We are in Australia now. So this is the Benarx Epoxy Panels on the bullet tank. So really large vessel. They have a requirement for high influx jet fired 30 minutes with a blast requirements nearly 0.3 bars. So yeah, not super high spec, but not so low as well. Yeah, we fireproof the tank itself together with associated components like a nozzle and the flanges. However, the saddle was fireproof with epoxy intumescent coating in the yard by the local applicator. Yeah, there were a couple of vertical vessels that we need to fireproof only the skid access holes. So you can see here nicely on that picture. Yeah. And now, yeah, the seventh case study is from South Korea for one of the petrochemical facility. Historically, they used the cementitious PFP. I think the thickness was 80 millimeter, if I could, 80 millimeter, if I could remember. And it wasn't in the good shape, in the good condition, start delaminating and deteriorating. So the end client want to fix it as soon as possible. So the area to be fireproof was 6 meter tall. The diameter of the skirt was around about 4 or 5 meters. So we fireproof this with our panels with only 8 millimeter thickness, so the lowest possible thickness we can offer. So yeah, successfully delivered and installed. This is the project in UK gas processing facility. We've been notified to supply our box solution for a removable PFP of the manholes and the nozzles. As you can see here, for a tank shell, they use the wet apply PFP. Worth to mention that in the background, you can also have our other boxes for other applications like actuators. Yeah, and we are finally in Norway, so hand over the lead to Adrian now, since this is his third region.
Yeah. Yeah, this is from an onshore facility in Norway. What's a little bit unique about this vessel skirt job is that we received an inquiry to not only fireproof from the outside, but also fireproof the skirt from the inside. Of course, when we fireproof from the outside, we kind of clamp together on the vessel skirt, but on the inside, we needed to find designs and methods to push out our panels against the interior wall of the vessel skirt. We used fixing methods along the pipe protrusions on the top and on this bottom sill that you see on the picture to basically erect the panels up against the wall. And also, and as you can see on the left picture here on the top, the vessel itself is insulated with AS wool. It was a significant high operating temperature on this job, so we also had to keep our tongue straight in terms of designing all the transition areas to avoid the temperature exposure of the epoxy. Of course, the epoxy has a limit what it can be in direct contact with, so we need to insulate and transition in an appropriate manner to avoid heat ingress.
All right, thank you, Adrian. And yeah, we supplied many other projects, but of course we have a limited time for this webinar. So for other projects, we would like to only show you a couple of photos. These are from a gas processing plant, offshore platform, and FLNG for removable PFP of the manholes. Yeah, similar cases, this time from LNG liquefaction plant, offshore platform, FPSO, majority for the PFP of the manhole. Here you have an example of the removable PFP with our boxes on the skid access holes, and this is manhole in the bullhead. So slightly different application. All right, worth to also show how our product will be lasting in the time 10, 15, 20 years frame. So of course, this is not easy to get from an end user due to the many different requirements like data protection and etc. But we managed to get some side photo of our product after certain of years. Maybe not from the vessel, but we would like to show at least what we've get so far, and it represents quite good performance of our product. So here you have example of our boxes on a ESDV from UK for actuator and for a valves after 7, 8, and 5 years respectively. And this time for onshore, previously was offshore, now onshore. We supplied a lot of boxes for this project in 2007 for many different applications, unfortunately not for a vessel. And we have been called to inspect those boxes after 10 years, and this is how it looks like. We are not telling you that it looks like a new from the factory, but taking into account several conditions like different weather for the climate zones, yeah, sometimes winter, sometimes sun, temperature variation, multiple shutdowns done and performed, local impact by the human activities over there. We are thinking they are looking pretty okay. Track records. So yeah, that's also important for the project that might be interested in our solution. Well, we have a lot of track records. That's number one, and that's supposed to give enough confidence with to the potential project that we are potential right solutions for the right application. For the floater market like FPSO, FLNG, etc., we have over 38 track records for worldwide projects. Track records even longer. It's too little space for the text, unfortunately. But we originally come from an offshore sector, so we supplied a lot of our products to the offshore platforms worldwide. Onshore, we are also getting stronger. According to our internal list, we have over 50 track records for the downstream. So, and also for projects in Asia, in Australia, Middle East, Africa, Europe, North and South America. So we are placed everywhere. So our solutions are exposed for various weather conditions and they are functioning as intended. So I would hope that it will give you enough confidence to trust in our technology. All right, we are entering the end phase of this webinar, so time to wrap up. So what are advantages of our epoxy panels? Of course, for the vessel, of course, that depends on the benchmark, to what solutions you are benchmarking us with. If it's static fine insulation with metallic jacketing or wet apply PFP, but but summary, it's the following. First of all, you don't need to paint. You don't need to make the surface treatment. There is no grid danger for the people and machinery. There's less workers on site, so there's a less safety risk. That's a very important for an offshore sector, but onshore as well. And basically what we do, we are removing the scope of the work to be done on site to our factory. So you are eliminating that risk, and we are able to fill the really tight schedule jobs. Also, amount of the scaffolding and weather protection covers are reduced. Our solution is fully compatible with any coating systems like zinc rich primer, polyurethane and acrylic top coat, thermal spray aluminum, or any other thermal insulation solutions. Our product can be installed on top of old defect PFP if it's required as well. There's no need to remove that. They are very easy to install by local workers. We can supply the field supervisor. There's no limitation when it comes to the installation. It could be any weather, and the installation will not stop. It's a very robust and durable product, so we can withstand the human traffic impact, step in, step out, this kind of the thing. It's truly removable and reusable. So once you remove it, you can put it back. It won't be destroyed. Of course, it's possible to destroy the product, but you need to apply something really heavy on top of that. It's very well tested and certified, and actually that's thanks to Adrian, a very good contribution to this. So we never had any issue to fulfill any certification requirements stated by the project. So we are safe here. We are safe option for the project. It's a load weight. It's starting from 11.7 kilograms per square meter. So our solution provides relatively a low weight impact for the metallic substrate. Lifetime of the product is basically lifetime of your product or lifetime of the pressure vessel. So we are in the same page. You don't have to replace that product after 5 or 10 years. Mitigates the corrosion under insulation, very also important. So it's basically maintenance free. And there's no need for a hot work. There's no welding, so it's just cold installation. And there is a very little waste during the installation. So, and they are treated as a general construction waste. That's it. So thank you very much for your attention. Hope that you enjoyed our webinar. If you have any questions, feel free to contact that email. We are make sure that we will respond on your any query related to this webinar, or maybe some requests for information. If you are interested to follow us on LinkedIn, feel free to do that. From time to time, we're trying to post some nice content for the industry. And thank you very much. And by taking this occasion, we would like to wish you a Merry Christmas and Happy New Year. Thank you very much. Okay.